Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is the question in front of me, May 2019. This is an interesting question. The question says optimization question. A cone with a radius r centimeter and height AB is inscribed in a sphere with center O and a radius of 8 centimeter. OB is equal to x. So the OB is equal to x, and the radius of the sphere is 8 centimeter, and volume of sphere is given, and the cone as well. The question says 9.1 calculate the volume of the 9.1 question says 9.1 the question says calculate the volume of the sphere. I'll show you now. So the volume of sphere, the formula is given 4 over 3 pi r cube. So I'm gonna substitute the radius, which is 8 centimeter, into the formula. So it's gonna be a 4 over 3 pi, and the r value we got now 8 cube. I'm gonna simplify with calculator. The answer gonna be a 2048 pi over 3. You can solve the pi or you can leave just like this. Second question says, show that r square is equal to 64 minus x square. Second question, we need to show that r square is equal to 64 minus x square. I'm going to apply the Pythagoras here. So must remember, this is the radius as well, because center O, so this is also going to be 8. Now, r square plus x square is equal to 8 square. We apply the Pythagoras. This is a right angle triangle. R square plus x square is going to be equal to 8 square. I apply the Pythagoras here. And now we need to isolate the r square. It's going to be a 64, x square become minus 64 minus x square. So they we proved. Last question says, determine the ratio between the largest volume of this cone and the volume of the sphere. I'll show you how. This 9.3 is an interesting question because we need to determine the ratio between the largest volume of this cone and the volume of the sphere. So we need to find the first of all here the height of the cone. Must remember, this is the height of the cone, 8 plus x. So this is our h. So h is going to be a OA plus OB. And because we have the radius 8 and OB is x, so the height of the cone is h. So OA plus OB. So which means h is going to be equal to 8 plus x. H is equal to 8 plus x. Now, the volume of the cone is given by the formula, which is V cone 1 over 3 pi r square h pi r square h. This is the volume of the cone. So I'm going to substitute all the information what I have here. 1 over 3 pi r square, must remember, is equal to 64 minus x square. So 64 minus x squared, and the h I got 8 plus x. So I'm going to FOIL this one. First I'm going to multiply this binomial 1 over 3 pi. Now I'm going to use the calculator. 64 multiply 8 is 512. I'm going to expand this one. Expand the expression. 64 plus 64x. Now multiply minus x squared with 8. For 64 with 8 and x, then negative x squared with 8 and x. So negative x squared is going to be a negative 8x squared. And the last one, negative x cube. Now I'm going to multiply 1 over 3 pi inside. So it's become 512 pi over 3 plus 64 pi x over 3 minus 8 pi x square over 3 minus pi x cube over 3. Now I can see here the 3 is denominator. I can get rid of the denominator. I divide whole term. I multiply whole expression by 3. I can get rid of the fraction, multiply whole expression with 3. So we're left with 512 pi plus 64 pi x minus 8 pi x square minus pi x cube. But remember, when you're going to multiply these 3 and 3 cancel, numerator and denominator. Now still I can see the pi is common here, so now I can divide by pi, and then we're left with 512 plus 64. Pi and pi gonna cancel because denominator is pi, numerator is pi. Pi and pi cancel, only left 512. 64x, and then this is gonna be minus 8x square minus x cube. Now I can rearrange here. It's going to be a negative x cube and negative 8x square and plus 64x plus 512. Negative can multiply inside, so only left with x power 3 plus 8x square minus 64x minus 512. So this is a volume of the cone. Quite lengthy calculation. Now to find the maximum volume, differentiate volume of the cone with respect to x and set the derivative to 0. So this dv over dx is equal to must be equal to 0. So I'm going to apply the derivative here. So this is going to be 3x square plus 16x minus 64 is equal to 0. The derivative of constant is going to be a 0. So now I can solve here. I need to apply the quadratic formula here to solve for x. So it's going to be a minus 16 plus minus 16 square minus 4 multiply 3 negative 64 square root over 2 multiply 3 negative 16 plus minus 32 over 6. But remember, I use the calculator. Now since x must be a positive, x must be a positive as it is a length, so we take a positive x value. So it's going to be a x is equal to negative 16 plus 32 over 6. The answer gonna be I'm gonna use the calculator, 8 over 3. X equal to 8 over 3. I substitute into this expression, original expression, plus of x. And now I'm gonna simplify. So answer gonna be a 1 over 3 pi. This become 512 over 9, and that becomes 32 over 3. Now I have to again multiply, use the calculator. So it's gonna be a 16,384 over 81 pi. Pi you mustn't solve, leave just like this. Now we need to calculate the largest volume of the cone, which we have now. The volume of the sphere is, we already have earlier, 2048 pi over 3. Remember, this is the volume of the sphere. Earlier we found. Now we need to determine the ratio. The ratio is volume of the cone over volume of sphere. We must remember volume of cone, maximum volume of cone we already find. Remember, he want in the question, he say must determine the ratio between the largest volume, which means maximum volume of cone, and the volume of the sphere. Volume of the cone we have 16,384 pi over 81 over volume of sphere we have 2048 over 3 pi. Now I need to simplify here. 16,384 pi over 81 multiply, this become 3 over 2048 pi equal to, now I need to simplify here, use the calculator. So this pi and pi gonna cancel, and you simplify with calculator. With all calculation you come with 8, you left with 8 over 27. Sorry for this one, 8 over 27. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.